So good afternoon, student. So today we have discussed a experiment on determination of BOD, means biological oxygen demand. The aim of this practical to determine the biological oxygen demand for the given water sample as per IS 3025. So introduction: the biological oxygen demand determined is a chemical procedure for determining the amount of dissolved oxygen needed by aerobic organism in water body to break the organic material present in the given water at certain temperature over a specified period of time. So BOD of water or polluted water is amount of oxygen required for the biological decomposition of dissolved organic matter to occur under standard condition at standardized time and temperature. Usually the time is taken as 5 days and temperature 20 degrees Celsius. Next, for environmental significance, BOD is the principal test to give the idea of biodegradability of any sample and strength of waste. Hence, the amount of pollution can easily measure. Efficiency of any treatment plant can be judged by considering influent BOD and the influent BOD, and so also the organic loading rate. So, following are the materials is used: BOD incubator, burette and burette stand, pipette, wash bottle, and number of chemical is used. There are 15 number of chemical is used for determination of BOD. So this is a BOD incubator, then BOD bottles, then pipette, conical flask, measuring cylinder, burette, burette stand, and these are the chemical required for the determination of biological oxygen demand. Okay. So start our practicals. So the aim or objective of practical to find the biological oxygen demand by given water sample. So first take the 200 ml of sample in 2 BOD bottle and dilute with water. Fill the bottle with the help of measuring cylinder. Take the water sample and fill the bottle. Give the label of the bottle, bottle A or bottle B. Then the question is, why sample of bottle is completely filled up to the neck? So the answer is to avoid the mixing of air bubble with the sample. The answer is correct. Then go to the next step. Then add the 1 ml of magnesium sulfate in sample A. Go to the next step. Add 1 ml of alkali hydroxide. For sample water A. So go to the next step. Mix the solution by inverting the BOD bottle upside down for 25 to 30 minutes. So 25 to 30 times. To follow those precipitation, this precipitation is go slowly down and down. So same procedure for bottle B also. So add a 2 ml of concentration H2SO4 in bottle A. So take a 200 ml of sample in conical flask using pipette. Now go to the next step, titration against sodium thiosulfate, 0.025 normality of sodium thiosulfate. Go to the next step, titrate against sodium thiosulfate till the blue color becomes colorless. So add the starch indicator. Starch indicator added in water, the color change to blue like this, and titrate with sodium thiosulfate, the color becomes colorless. So initial purity rating is 0 and final purity rating is 6.4. So what is the normality of sodium thiosulfate? Is a 0.025. So your answer is correct. Go to the next step. So the volume of sample is 200 ml. Initial purity is 0. Final purity rating is 6.4. And the volume of sodium thiosulfate is 6.4. Which is the following indicator is used during the titration? So torch indicator is used during the titration. So go to the next step. So BOD BODB sample is kept into the BOD incubator at 20 degrees Celsius for 5 days. So set the temperature 20 degrees Celsius. After 5 days, open the door of the BOD incubator, take the bottle out. What? Why BOD kept in BOD incubator? So this answer to prevent the DO. Then take the 1 ml of the MnSO4 magnesium sulfate in BOD bottle B. Sample B is kept in incubator at what temperature? So it is a 20 degrees Celsius temperature. So go to the next step. Add the 1 ml of the alkali iodide azide So close the bottle, open the knob of the sample B bottle, and add the 1 ml of alkali azide. Shake the bottle. Go to the next step. Shake the bottle. The precipitate is settled down at the bottom of the bottle.